Okay, so moving on to problem 3 and working towards the end. Again, we have a compound inequality. It has this AND statement in the middle. When you run into these compound ones, you've got to solve each one separately and then graph them both to figure out what your solution is. Okay, left side, I have my variable on the left and there's none on the right, so I'm going to just keep it on the left and get rid of the 2. So I'll get 3x is less than 3. I'm going to divide by 3 now to get x by itself. Give me x is less than 1. Okay, that one's pretty quick. Right side, it's same situation. So I need to get rid of my constant term. To get rid of subtract 6, I'm going to add 6 to both sides. And now I got 4x is less than 16. Divide by 4 to get x by itself. And now I got x is less than 4. Okay, so we got two conditions. X is less than 1 and, notice the and, x is less than 4. Okay, so let's graph both of these on the number line. We have fairly low numbers, so I can put my tick marks pretty far apart and count by 1. 1, 2, 3, 4. Okay. I'm going to graph the x is less than 1 part first. Again, open circle, and I'm shading left because it's the numbers less than 1. So the red shade is going to be my left side. And I'm going to switch to green because Christmas colors rock. And I'm going to graph the right side one. So I need to open circle at 4. And I'm going to shade left again. Shade left. Okay. So now I'm figuring out what, out of the whole number line, what is the solution, what satisfies our left side and our right side. It's any part of our graph that got shaded twice, which is basically from 1 and left. You notice this section here does not have double shading, so that's not in the solution set. It's only the part that got double shaded, which was over here on the left. Number 4. This one, I keep the fraction problems on the homeworks because they're hard, and I'm just hoping that if we keep working on them, they won't be as hard eventually. So we have 2/5 times this quantity, x minus 2. With this, we need to do something about this fraction. We can distribute and do 2/5 times x and 2/5 times 2 if we want to, or we can try and get rid of the 5 to start with. I'm going to go with the distribute method because you guys are used to distributing. So I'm going to do 2/5 times x and 2/5 times negative 2. Well, 2/5 times x gets you just 2/5 x, and 2/5 times negative 2 gets you negative 4/5. When you multiply fractions, something like 2/5 times 2, well, you multiply across the top, and you multiply across the bottom. 2 is really 2 over 1. Multiply across the top, multiply across the bottom. Okay, so that's 4/5, and that's all greater than or equal to 6. Now I still want to get x by itself. Well, let's get rid of this 4/5 stuff by adding 4/5 to both sides. Add 4/5. On the left we have 2/5 x is greater than or equal to. So I can write just 6 and 4/5, but I'm going to turn this into a improper fraction because later I'm going to have to get rid of 2/5, and to get rid of 2/5 is to divide by 2/5 or multiply by the reciprocal, which is the same thing. Okay, so this as a improper fraction is 5 times 6, and then you add 4. Multiply bottom times front, add the top number. 6 times 5, 30 plus 4 gets you 34. Now at this point, I need to get rid of the 2/5. this is really multiply by the reciprocal. If you don't remember that little maneuver, look it up. But the reciprocal of 2/5 is 5/2. And you just multiply both sides by 5/2. The 2's will cancel, the 5's will cancel, and all you got on the left side is x. And it's still going to be greater than or equal to because we've multiplied by a positive number. On the right side, you can do 34 times 5 and then put it over 2. Or you can do some division beforehand, some simplifying, and realize that 2 goes into 2 once, and 2 goes into 34 17 times. And so now you got 17 times 5 across the top. And when you multiply that out, you should get something like 85. And it's over 1. So x is greater than 85. I'm going to skip ahead and graph that real quick. So x is going to be greater than 85. I'm going to put 0 over here and just count by tens. So it's going to be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 80, that's 90. 85 is here-ish. Let me glance real quick. And we're looking for greater than or equal to. So that's why I filled it in, because it's equal to. And I'm going to shade to the right. So there's our graph for number 4. And I'm going to pause, and apparently I'm going to make 3 recordings.